Okay, you guys remember we have an order of operation that we were going through. Last time. And let's see, do you guys remember what was that? That was, please excuse my what? Dear Aunt Sally. First, second, third priority, fourth priority. Sure, come on in. And if we had the same priority, we work how? Left to what? Left to right. Okay, if we only have the same priority. Okay, so we'll do a quick review from what we looked at last time. So some of these problems, for example. The difference between things like this, right? 5 squared versus negative 5 squared. And then negative what? 5 squared. Each one of these problems are what? Are different. Okay? So these are all different. So let's compare and contrast these at the same time as review from yesterday. So you guys remember you have an exponential. What's the base here? It's positive 5. What's the power? 2. Okay, so by definition, this is repeat multiplication. That's an exponential. We repeat the base of 5 2 times, and the operation for exponentials is always what? Multiplication. So what's 5 times 5? It's 25. So here's our answer from yesterday, our review. The answer here is 25. Now compare that to this. What's the base here now? And the base is going to be what? Is it positive 5 or is it negative 5? It's negative 5. Okay? Because this set of parentheses is emphasizing that what's inside the number is negative. So this is your base. And so you have negative 5 times negative 5. You can put the set of parentheses to emphasize these numbers are negative. You can multiply again here. And now we have to simply remember that negative times a negative is what? Positive. And then 5 times 5 again is what? 25. Okay? So here we go. Okay, is everybody okay with this one? Okay. Now, how did this work yesterday? How do we see this work? Exactly. What's going on here? There's a little more going on. In other words, we talked about yesterday that the base here is actually positive. It's not negative. If they wanted to have this base be negative, what would they have done? Put the parentheses. Okay, so they didn't do that. So then, that becomes, well, what does this really mean? Well, like the tattoo, does anybody want to tell me that tattoo that we used yesterday here for this was? What was that tattoo? Good. That negative triangle is equal to what? Negative 1 times our what? Triangle. In other words, anything that's negative can be described as negative 1 times that thing that's not negative. So this now becomes negative 1 times what? 5 squared. So we worked on this yesterday. Here's where your order of operation came in, kind of as a review. You got multiplication, you got an exponential. What takes priority again? The exponential over multiplication. So you guys know that this will give you negative 1 now times 5 squared is what? 25. What's negative times a positive? That's negative. So this is kind of the foundation of review that we did last time. And these are the tools that you guys want to use. The tattoo applies to this scenario. And this is where people kind of commonly make their mistakes. Okay, you guys okay with that? Okay. So did you download some of these homework? Did you guys download this worksheet? Right? Entitled what? Order of operation. And it's a review. Okay, do you guys remember where's that at? It's on the website. Is that true? Okay, so it's the first week. You know, you may not have your book yet, and you know, we'll give you some time to get your book. You understand that? Also, what else is going on? Yeah, so this week we'll do some review, and we'll just use these handouts for it. But anyway.
Oh, I didn't have that.
You didn't get the syllabus?
I do not. I do not have these.
Oh, you don't have that. Oh, okay. Well, we'll have to talk about that and see how you could download it. So you could get that at home. Yes?
Do we have to download it or can we copy it?
You can copy it. You don't have to download it. You can even look at it on your phone or on your computer, you know. Okay? Let's take a look at some of these. Let's do a quick remark before we go into more detail. Let's note, some of you guys asked this question last time. It's a good question. What if you had a negative of a negative 5 to the what? Second power. We'll keep with this concept. Remember, this question we noted last time. So with the negative 5 to the second power, what you guys are going to use is that tattoo. Is that true? Because that negative, what did that negative mean again? It was code for really what? Negative 1 times what? Negative 5 to the second power. Okay? And so now, by order of operation, you do your exponential before multiplication. So it's still negative 1 now times, and you know negative 5 to the second power is what? 25. So you got your negative times a positive again, and you get negative 25. So this is a very common question that people look at and can make mistakes with. We're going to see later how this even works with absolute values. Absolute values are different. Sometimes in algebra classes, they'll give you order of operation with absolute values, so we'll cover that too. But I just want to point out to you these basic tools, and these are what we're going to use. Okay, anybody have any questions on these here? No? You sure? All right, well. Okay, can I erase this sort of review that we had? Okay, so let's take a look at some more detail of that handout. And here we go. Some of you guys who, let's look at this here. We'll do some more of those problems for review. So, for example, did we do this one yesterday? The 27 plus 16 times 9 minus negative 20. Did we do that one? Okay. So we didn't do this one. But let's take a look at these operations here. What do you guys see as operations? We see the addition. What else? This dot means multiplication. And what's this? Subtraction. And then you got this negative 20. Why did they put a parentheses? Do you guys know why is that parentheses there? To simply emphasize that the number you're working with is negative. Okay? So these are the operations. Now, order of operations says we do what first? We do the multiplication before what? Addition and subtraction. So you want to go with this. Now 16 times 9, do you guys know what 16 times 9 is?
144.
Is it 144? What do you do if you do not know that answer? What do you guys do if you don't know what this answer is? Exactly. I'm going to say to you, you don't reach for the calculator. Right? You don't try to say, well, this is where I stop. Okay? You want to review your math algorithms, your arithmetic algorithms here. Okay? This is a single digit multiplied to a double digit. What's 6 times 9? Is that 54? Is that true? So you get the 4, carry the what? 5. 9 times 1 is 9. Now plus 5 is what? So you're right, it's 144. So I want to point this out to you guys. Okay, you guys okay with that? That's what you do. That's what I would do. If I don't know an answer in arithmetic, I just bring out my algorithm and go through the steps. You know, no big deal. And then what do you guys notice you have here? What do you have? 27 plus now 154 minus that negative 20. Okay? So you have addition and you have what? Subtraction. So what do you guys notice about the order? You have addition and you have subtraction. What does order of operations say? It says that really what? Addition and subtraction have the same priority. Yeah, the same priority. In other words, one is not more important than the other. Now, if you're in that sort of situation, how do you work? Left to right. Remember, you work as you read. Addition's not more important than subtraction. They're the same priority. It just happens to be that the addition is on the what? On the left. Is that true? So what's 27 plus 144? It's 1 what? How did you guys know this? You did your algorithm, right? And then you're going to subtract a negative 20. Now, this is kind of something I didn't go into detail yesterday about, but this is still kind of review. How would you guys handle this? Huh? I mean, what does this mean? You got minus a negative. Do you guys know what that means? Let me explain something to you. Okay, we could look at it from a different perspective, a couple of points of views. So I'm going to call this a note. Let me explain it to you in a way that you already know, meaning minus negative 20, if we use the tattoo that I erased, what does that minus really mean again? Right? See this negative sign? What does it mean? It's negative 1 times what? Times a negative 20. Now, what is negative times a negative? It's positive. 1 times 20 is what? 20. So this answer here is really what? 20. Are you guys okay with that? Okay. This is one way to look at this. Sometimes some people look at it this way. What's the opposite of a negative? It's a positive. We don't put the positive sign here, but it's understood to be positive. So if you look at the opposite of a negative being positive, that's one way you can also see it. Okay, this is the mechanics really of what's going on. But what I want to really say is 171 minus a negative 20, this problem really becomes 171 what? Plus 20. Good. Okay, so you guys remember order of operation. So sometimes students will say, hey, does that change to a plus? And in a sense it changes, but there's actually things going on here. It's the opposite of a negative being what? The positive. So now you can add 171 with 20, and what do you end up getting? You get 191? And that's what you have in the worksheet. Okay, are you guys okay with this? Okay, anybody have any questions on this one? Is that easy or is that hard? That's easy? Did you guys go home and pay your parents' bills like I asked? No? Okay, well, we'll see some more of these problems. Let's look at, for example, on this worksheet. What do you guys see? What's a difficult one? Did we do number 22? Should we do an easy one or a hard one? Let's look at some more. 28. 28? Okay, we'll work on those, but let's try to do something like this. 43 minus 6 to the 4th minus 5 to the 3rd. So some of you guys know that this is number 25, okay, on our worksheet. So we'll go through some of these. What does order of operations say? You got subtraction, you got subtraction, you got a couple of exponentials. So which has the highest priority, the exponentials or subtraction? The exponentials? Okay, but you have two. Which one do you do first? You do the one on the left. Good. So be careful here. Those are subtraction symbols. So if you do the exponential on the left, make sure you do what? 6 to the 4th power. So what is 6 to the 4th power? Do you guys know? 1296. It's 1296? Okay, good. So we replace this with a 1296. What about 5 to the 3rd power? What's that? 125. Good. Now the subtraction operation is still here, and you're going to bring down your what? Your 43. And this is a very interesting scenario again. Okay? So let's go through this. You have two subtractions, and you know if it's the same operation, it has to have the same priority, right? It's the same priority. Which one do you do first? the one on the left. So we're going to work on 43 minus 1296. We're going to have to be careful here, okay? This again, for algebra students make mistakes on this sort of scenario. And we talked about that yesterday, right? What is the easiest way to go about answering that question?
Subtract 43 from 1296.
Yes, in other words, what you learned back in Math 120 is, let's note, you simply want to take the difference between these numbers. So there's an algorithm that you learned back then. You got 43 and you got 1296. Now, you're used to doing this sort of arithmetic. That's what you're used to doing, where the larger number is positive, the smaller number is negative. You're used to that. And so when you got 1296 minus 43, you bring out your algorithm of subtraction, and you go 6 minus 3 is what? 3. What's 9 minus 4? 5. And 2 minus 0, well, that's a 2. And this is 1 minus 0, that's a 1. And you say, yeah, that's 1253. But that's what you're used to doing in a class, a math class that doesn't consider negative numbers in a sense. This class, or the class before, you learned all about negative numbers. And the recipe they showed you here to perform this kind of difference is that you now have to go back and consider what? What do you guys now have to consider? This is not 1296 minus 43. This is 43 minus 1296. That's a different answer. So what rule do you use here to deduce the answer? Do you guys remember? What was that second part of this kind of subtraction from Math 110? What did you guys do? Anybody remember? What do you guys think? Why are you going to use a negative sign? Why is it that this answer is actually a negative 1253 and not a positive 1253? Because the larger number, 1296, is what? Negative. So this is going to be really negative 1253. Now, minus a 125. This also is something we have to talk about. I know I talked about it with the second class, but yes, that's what you're going to use. Okay, you guys okay with that? Is that easy or hard? Well, take the difference and use the sign of the larger number. Okay? That was the summary of the techniques you learned. I'm going to erase this. You guys okay with me erasing this here? Okay, because we're kind of limited with the board space we have, I guess. Oh, I hope we're not going through here. Well, we might be. Oh, I'm going to have to erase all this over here then. Okay, I'm sorry. Thought we were good back over here. Or not. We might be only okay, well, whatever. We got negative 1253 minus a 125. Okay? So let's ask you guys this question here. I think I talked to this other algebra class about this. What does this mean? Do you guys know what it really means? Right. I think we talked about that maybe. Okay. If I told you there's no such thing as subtraction, but what? Addition of a negative. In other words, this problem is really negative 1253 now, not subtraction, but what? Plus a negative 125. This is what I called, for people, this is what I called the other day paying your what? Parents' bills. Okay? This is how bills work. This is money that comes out of your pocket. So if you owe 1253 and then you owe another 125, this is owing. You're really adding two bills. Is that true? So how do you deduce the answer? Do you guys remember how you deduce the answer when you add two negatives? Well, here's what you do. Are you going to end up owing when you add two owing situations? So you owe. You okay with that? And what you're going to do is really add 1253 with 125. Now you're probably going to do this what? Horizontally, because you're going to use your addition algorithm. So you get 8, 7, 3, and 1. But this is the total of your bills. Your bills look like this. They never put the negative signs. So if you have a bill for $12.53 and $125, you add your bills, $13.78, and what's the story? You actually owe that kind of money. So your final answer is a negative what? 1,378. 1,378, and the answer is negative. So this is how we deal with the two bills situation. Okay, you can have 3 bills and 4 bills, and as we talked about yesterday, parents have a lot of bills, right? They just don't have 1 or 2, they have a lot. So this is kind of how you do that arithmetic when you owe. All the values are negative and you're adding. Okay, everybody okay with this one? You sure? Should we work on some harder ones, or is this still too easy? Some what? Okay, let's do some harder problems. Good. Let's warm up though first with 26, and then we'll do your favorite 28. Or should we do 20? Did we do 27 yesterday? No. No? Should we try 27? Let's try 26 and warm up, and then we'll do 28. We'll do the evens. 2 times 4 minus 7, and this is going to be raised to the second power. Okay, so let's take a look at this. Multiplication, subtraction, your exponential. Okay, what isn't described in order of operation, and we wrote this yesterday, parentheses, you really do with what's inside the parentheses first, right? So we talked about that yesterday. We do with what's inside. Okay, fine. But this is a little different. Do you guys know how this is different? What do you notice? We got, in a sense, what? Your parentheses is here. And then you look at this here. What is this called? Brackets. They're brackets, and they're really called square brackets. Okay? So these are square brackets. So how do you work when you have a parentheses inside a square bracket, or in some ways a parentheses inside of another parentheses? They never notate that kind of thing in order of operation. Please excuse my dear Aunt Sally means parentheses, exponentials, multiplication, division, addition, and subtraction. Is that right? Same priority, work left to right. So when you have this nested sort of situation, a parentheses within another parentheses, or bracket in this case, how do we work? We work with, we say this is inside what? Out. That's how you work. Inside out. Okay, so what does that mean to work inside out? You work within the innermost parentheses first, and you work your way how? Outside. So what that means is, here's the innermost parentheses. Is that true? So you got 4 minus 7. Go back and think about what we just talked about. 4 minus 7, what's that going to be? Negative 3. So this value is negative 3. So if I write everything down again, this is 2 now times parentheses negative 3, bracket squared. We have done the first thing that we do here. We're working how? Inside what? Out. You okay with that? Everybody okay with this here so far? It's not a big deal. Now what do you see? Are you done working inside out? Nope. You got the bracket still here. It works like a parentheses. How do we deal with parentheses? We do the work that's what? Inside. Here is inside this bracket or parentheses. And the arithmetic to do is a multiplication problem. You're multiplying 2 with a what? A negative 3. And what do you get? Good. You guys get negative 6. Good. So you get negative 6 to the second power. The bracket is just like a parentheses. I'm keeping the notation of a bracket, but what you guys are looking at again is a negative base to the second power. Okay, so this is called an exponential. So be careful. When we have this nested situation, we work inside out. Now you have that exponential. What's negative 6 to the second power? Is it positive or is it negative?
Positive.
Okay, good. Why is it positive? Because negative times a negative is what? Positive, and you're done. Okay, so this is number 26. You guys okay? Yeah.
Do we always have to bracket it for the final answer, like before we solve the exponential?
No. Do you guys understand her question? Do you really need to write this next step?
Do we need to always put brackets so that we know that it's the base is -6, as whereas if we did -6 without the brackets, it would be -6 times 6?
No. It's not. It's going to be, remember, the definition of it's not going to be -6 times 6.
Yeah, so that's
It'll be a -6 times what? -6. You say, well, why is that? Because the base is negative. The definition of an exponential was repeat multiplication with that exact same base. So yeah, never change your base.
We always bring down the brackets for that.
It's up to you.
Oh.
I think personally for some people, they see this like this. I mean, I know I do. And I go, you know, that's just an exponential with a negative base, the second power, -6 times -6. That's positive 36. I know that. So if you do that, is that okay? Sure, that's okay. Do you have to go through every gory detail like I do? What do you guys think? Only if it helps you, I would recommend you go through details. I mean, if you're the kind of student that I was, I had to go through every detail. I mean, I was the kind of student that's pretty much like everyone else. Okay? And you say, well, what do you mean? I don't want to write all this work down. My hand will hurt. My hand used to hurt after I did my math homework. You know, if I wrote everything down. So I said, I'm not going to do math homework. I don't like pain. But what happens if you don't write things down sometimes this way? You don't really learn the process. You don't enforce the process. So what I would say to you is you got to know yourself. It's up to you. I highly recommend you go through these details until you become a what? Master. See, even myself, if I had to do this problem without teaching it to people, I wouldn't just stare at it, you know, positive 36. I would never do that. Because if you notice that you're going through 1, 2, 3 types of operations really before you deduce the answer. Your brain can only do 1 type of operation at a time. You can't do all 3. So if you find that you can't stare at this and know an answer, well, that's normal. Nobody can. You're going to need to go through these steps. Now, people who deduce this at times in their head are going through these steps and they train themselves to know the answer in the sense that, okay, this is my first answer, this is my second answer, my third. I'm not like that. Most people aren't. You're going to have to write that down, I think. So it's up to you. You know, you want to put these brackets there, it's up to you. But I think it's good to reinforce the concepts until you become a master. You know, that's kind of how I look at it. Does that sound reasonable? Okay, so that's a 26. Let's look at 28. Okay, so look at 28. That's weird. Oh well. Has been off for a while. Oh, okay. Gotta get my money back. Get my money. What's going on with these guys? Shouldn't be the case. All right, parentheses and what? Your brackets here. Work inside out, meaning we have to do the work here that's on the inside of our parentheses. And what we use here is order of what? Operation. So note, what's on that inside is 5 cubed minus 2 squared minus what? 4. That's inside your parentheses. We're going to evaluate this using order of operation, and we're going to see what this number is, and then after whatever value that is, we multiply it with 5. And we have worked inside out. So, okay, what does order of operation say now? Subtraction, subtraction into what? Exponentials. Yes?
Multiply 5 times 5.
That's true.
2, 5 times 4 times 4.
Oh, be careful. Be careful. This is not times. This is what? These are subtractions. You got an exponential and another exponential.
Oh, yeah, yeah.
Be very, very careful.
Yeah.
Okay? So, which exponential do you do first? Since exponentials outrank what? Subtraction. Which exponential do you guys do first? The one on the left. 5 cubed. And what is 5 cubed? 125. Good. What's the one on the right? 2 squared. What's that? 4. You guys okay with this? And this is subtraction. And then this is another subtraction of what? Of 4. So you get 125 minus 4 minus another 4. These are subtraction problems. So if they have the same operation, they have the same priority, which one do you do first? The one on the left, because you work left to right. 125 minus 4, well, what is this? You guys know? What's 125 minus 4? It's 121 minus now the 4. This is the next subtraction problem. And what's 121 minus 4? So 117? Good. That's 117. Is that your final answer? That's only this right here, 117. So if I write down the other information here, I'm going to just put it over here. This is 3 cubed, an exponential, minus bracket 5. Now this is times 117. Don't forget this is raised to the second power. You may notice that I did not put down parentheses for my answer. Can I? Sure. I can put a parentheses here. But when do we usually put the parentheses there? When the number is negative. And the reason we do that is to emphasize that that's a negative number. So I can put parentheses, or I can what? Leave it alone. Okay, you guys okay with that? Now let's take a look at this. Wow, this is a... God, that publisher, what did they do to us? What's this? What's 5 times 117? What is it? Are you sure? Yes. So in other words, you're still working inside out, inside this bracket, thought of as a parentheses, is multiplication. You guys are telling me this is 5 what? 585? Okay, I believe you. So this is now 3 cubed minus 585. Don't forget it's to the what? Second power. What I'm saying to you is here is your subtraction. And here's 2 sets of exponentials. Which one do you do first? Exponentials outrank subtraction. Exponentials outrank subtraction in order of operation. So which do you do first? The one on the left. What is 3 cubed? It's 27. Good. 27 minus, wow, 585 to what power? The second power. Is that true? Okay. What is 585 to the second power? 300 and what? 42,245? 25. Anybody second that? Yikes. Yes. Oh, you guys second it. Good. What did you really do? Hopefully you did what? I'm going to erase this. Yeah, hopefully what did you guys do? Is there any shame in throwing your calculator away? No. Meaning, hopefully you did 585 times what? 585. This is 3 digits, 3 digits. There's some work to do. Is that right? Okay. Now, what is 27 minus that 342,225? How are you going to deduce this answer? Anybody know? Well, first of all, is the answer going to be positive or negative? Negative. How do you know it's negative? How is this? How do you guys know this is negative? Again, it's a subtraction problem. Is that true? We could look at it different ways. I've described it to you guys in different ways. So it's a subtraction problem. How do we do that again? You have to know the difference between 27 and this big number. Is that true? If we find the difference, what sign do we use? Positive or negative? Why negative? That's the sign of the what? The larger number. So your answer, ladies and gentlemen, is going to be negative. You okay with that? But before we actually write the answer down, I'm going to put here, we got 342, 225, 27. I'm going to take the difference between these two. In other words, I have some work to do on my scratch paper before I give the final answer. I'm notating it's going to be negative, though. And so let's do the work. What's 5 minus 7? Do you guys know? Well, I don't know what 5 minus 7 is in this context. In the context of our subtraction algorithm done vertically, how do we do this? I have to borrow. Borrow from the neighbor, right? What's 15 minus 7? 8. 1 minus 2? Got to borrow. 11 minus 2? 9. 1 minus 0? 1. And I could just bring down my what? Numbers. This is the difference between the two numbers. But as a final answer, what do I really write down as a final answer? Let's write it over here. Negative what? 342,198. Anyway. Okay, you guys okay with that ugly question? It's pretty big, and let's double check if we're right. Do you guys remember on my worksheet, this was number what? 28? Did you guys remember and see on this worksheet online on my website, number 28? Did we put the answers there for you? All right, you guys see number 28? Is that the right answer? I see that there. Okay, some of you guys will say to me, Mr. Judge, I can't download that worksheet. I can't print it up. What could you guys do? Okay, you can go to the library. Where else can you go? Huh? Some people do. But what else if you say, I can't do that? You can copy it. Why don't you come to my office during office hours? Can I print that up for you? What do you think? Can I print that out? You say, Mr. Judge, you know, can you print out that worksheet for me online? What can I say? Sure, okay, I'll print it out for you. Okay, so even if you have trouble getting it, come to me. We don't have office hours after this class. I have another algebra class. But what could you do then? Just come to me and we'll do what? We'll print it out for you. Okay, you guys okay with that? So, you know, you got something to work on for now until you get your book. And we'll do some work out of your book, believe it or not. We got to do some order of operation here. But anyway, is everybody okay with this so far? Yes. You want me to do 32? Oh, yeah, we got to have a discussion on 32. What's our time like? What time do we get out of here? Huh? 10:50? Okay. Well, should we talk about this? Let's talk about it. Good. Okay. This is review, and we're looking at order of operation. We're looking at some of these other questions that involve absolute value. Okay? So let me give you sort of a discussion on absolute value. Some of you guys probably know already. What? Yes. Yeah. It's a review. Yeah. Well, it's supposed to be a review, but sometimes it's not. Is that okay? Can you still learn if it's not? You still learn. So we'll be okay. Okay. Do you guys know the essence of absolute value? Huh? Do you guys know what the absolute value is? For example, here's the number 3. Here's the number -3. I'm going to put a dot here in the location of 3. Put a dot over here. Do you guys know what's so special about these two numbers? Do you guys know? Yes! Ladies and gentlemen, absolute value measures, and think of it this way, distance from what? From 0. This is what absolute value measures. How far is the number from what? 0. So if you want to think of this as being home, okay, that's home. How far is the number 3 from home? What are you guys going to say? Well, you're going to say this. The distance from here to here is what number? 3 units. It's distance, so we use this arbitrary unit measure. From 0 to 3 is 1, 2, what? 3 units. Are you guys okay with that? Yes. Anybody have any questions so far? What's the distance from 0 to negative 3? 3. Wow, this is where people are going to get confused. This is where people can have an issue. Okay? If I said to you, hey, did anybody here during the summer break, did you guys go to, anybody here go to Santa Barbara? Like me? Okay, good. How far is Santa Barbara? How far is Santa Barbara? What do you guys think?
2 hours.
Don't say 2 hours. You guys know why? How far is a unit of what? Distance. What did you give me? Time. Santa Barbara is not 2 hours. I know what you mean, though. It took you 2 hours to get there in terms of time, but you're not giving me distance. You're avoiding the question. Now, there is a relationship between distance and time, and that's really that, you're using concepts of speed associated with that. Okay, so the distance is going to be your speed times your time. So let's say you're traveling 60 miles per hour for 2 hours. Then it's 60 times 2, right? So you could say that Santa Barbara is how far away? 120 what? Miles away. Are you guys okay with that? No big deal. Anybody go to San Diego like me? Good. How far is San Diego?
Fell asleep on the way there.
Now nobody wants to give the distance. They're going to say 2 hours again. People usually say 2 hours. Okay, they'll say 2 hours yet again. Typically, that's what happens. Well, if you're traveling 60 miles per hour for 2 hours, again, how far did you go? 120 miles. Is that true? You guys okay with that? What do you guys notice the relationship between Santa Barbara and San Diego?
Different directions.
They're in different directions. And in a sense, they're in opposite directions. One's north, and one is what? South. Is that true? But what answer do you give whenever you talk about distance? And is that positive or negative? It's positive. You guys with me on this? Distance is positive when you move. There's only one exception, and that's when you don't move. In that case, distance is 0. So if you stood home and you didn't go anywhere, I said, how far did you travel? You have to say what? 0 miles, Mr. Judge, because I didn't go anywhere. 0 is a neutral number. It's not positive, it's not negative. Okay? So here's what I'm saying to you. If you move to the right and somebody says, how far did you move? You're going to say what? 3 units. You move north, or you travel north to Santa Barbara, you traveled 120 miles. Positive numbers. You traveled south, how far did you go? Still yet, what? 120 miles. So this is also 3 what? Units. In terms of measuring distance from where? 0 or home. Now, the notation is this. This is what you want to be familiar with. Notation of absolute value. I'm going to give you kind of, how I describe it in general. These vertical lines, these are not brackets and they're not parentheses. Okay? These are vertical lines. What this means is, this is the absolute value. They're asking you a question, really. What's the absolute value of the what? Triangle. And what you want to think of is really this scenario. How what? Far is the triangle from what number? From 0. That's right. That's what you guys want to know. So how this really works is that, for example, the absolute value of the number 3 is, how far is 3 from 0? 3 units. Good. How far is negative 3 from 0? 3 units. Good. So these two numbers, and again, if we wanted to put these dashes, this is where negative 1, negative 2, negative 3. If you walk from 0 to this number, you're walking 3 units. If you walk from 0 to the positive 3, you're still walking what? 3 units. So distance is independent here of the direction in which you travel. Like going to Santa Barbara or San Diego, you never say, I traveled negative 120 miles. You guys see what I'm saying? Nobody's going to know what you're talking about. Okay? All right. You question? You okay? Yeah. Yeah.
Sort of like the same with the parentheses question I asked.
I know. I could read your mind.
Negative
Exactly. I already know where you're headed. I could read minds. I already know where she's headed. We're going to talk about that. Because that's where people make a very common mistake too. Let's do a couple more of these. See if you're really awake first. And I want to keep everything on the board. We probably have to hire a camera person. Can't do that. We have to hire a camera person. You know what we're going to do. Because I'd like to use the rest of the board, and then they got to focus in, and you know. Yikes. I want to leave everything here. How about if I do this? Let me do this. Let's give you another example right here. See if you're really awake. What's the absolute value at 0? Why? How far is 0 from 0? You didn't move. This is the only time that you give 0 as an answer. The only time. Because distance is always positive when you move, but if you don't move, you communicate by saying you traveled 0 units. Okay, so if you didn't go anywhere this summer, you could tell all your friends, hey, I traveled 0 miles this summer. Okay, so can I erase this here? You guys have that in your notes? Let's work with that. I'm going to say to you how far, and this is kind of, you know, you don't really have to draw that picture anymore. They're going to say to you, what's the absolute value of, let's say, negative 11? Okay, what's the absolute value of, let's say, positive 13? What's the absolute value of, let's say, negative 1/2? All of these are going to be answers. Another example. What's the absolute value of 2.38? Another example. What's the absolute value of a negative 2.38? Another example. What's the absolute value of a positive 3/2? So could you guys tell me this now? What do you get? How far is negative 11 from 0? 11 units. How far is 13 from 0? 13 units. How far is negative 1/2 from 0? 1/2. Can you travel a half a mile? Yeah, you know how far my office is? It's a half a mile away. Not really. It used to be because I have to go to G8. Oh my God. It's like, how could I put on more weight if I'm walking every day like 3 miles? Absolute value 2.38. What's the deal? 2.38. Good. Absolute value of a negative 2.38. 2.38. Good. And the absolute value of 3/2. 3/2. Good. Now for the golden question, the one that's going to mess everybody up. I'm going to erase this here. Anybody have any questions on this? The one that really gets people all the time is when you have this example, negative absolute value, let's say of a positive 14. And I'm going to compare this one to negative absolute value. Well, let's do it down here. Let's compare it with a negative absolute value, negative 14. Oh, this is where we're going to have some fun. I'm going to get people every single time here.
Negative 14.
Well, I don't know. I have to think. What does this mean? Does anybody want to tell me? Huh? Yeah, what did that mean? Good. You guys are using the tattoo, aren't you? Negative anything can be thought of as negative 1 times what? That thing. You see this negative sign? That's your negative 1 times. I'll put this here in blue to emphasize. You guys are what? You guys are right. This is what I wanted to show you. That minus anything, using your tattoo logically, is negative 1 times the absolute value of 14. You have actually two things to do here. What's the absolute value of 14?
14.
That's 14. What's negative 1 times 14? It's negative 14. It's 2 steps. Similarly, what's that negative sign do? What is that? Isn't that negative 1 times what? The absolute value of negative 14 if I write every gory detail? Say yes. Be careful. This is not a parentheses. Absolute values are not a parentheses. It doesn't work the same way, exactly the same way. So negative 1 for this negative sign, we're using that tattoo. Negative 1 times the absolute value of negative 14. Can you tell me, the only way you can answer this question is if you know what the absolute value of negative 14 is. What is it? Now, what's negative 1 times that 14? Negative what? 14. Ladies and gentlemen, this is where you're going to have the problem. Yes?
So can the absolute values also be like coupled with the exponents too?
Yeah. The absolute values can be coupled with a lot of things. Now, before you ever really do the arithmetic, though, you're going to eventually evaluate your absolute value. In other words, notice that before you can give this answer, what did you really have to do? Answer the absolute value question for both of them. See that? So yeah, you're going to have to return an answer for the absolute value first before you even could proceed. So you got negative 1 times this absolute value, or negative 1 times the positive 14 gives you negative 14. But people, should I talk about the bad habit people have? The bad habit is that people want to see this as a parenthesis. That's really bad. And I can understand why you have the bad habit, because sometimes it's viewed as a parenthesis in a certain context, like you'll see in these examples. But it is an absolute value. And if you're going to answer any question, you do have to know the value of that absolute value first. Question?
So in that order of operations, where did you say?
Yeah, you don't. Do I see absolute value anywhere? I don't even see absolute value. Do you guys see absolute value? It's not even there. It's not there. I know. Can I erase this? Or should we put it over here? Let's put it over here. And then you say to me, if it's not even here, then why would those math people ever put what? Absolute value questions on order of operation review. Sometimes they do. They're combining a couple of concepts. So let me do a couple of them first for you here. Okay, should we start easy or start? How should we do this? Which one do you want to do? Huh? All right, should we just dive into it? Or should we just, okay. Well, I don't know, okay. Okay. Yeah, I know. You guys wanted to dive into it. I'm not so sure. How about if we do this? Let's do -8 minus 5 in absolute value first. Just to get you guys kind of warmed up a little. So tell me, you got absolute value, is that right? You could only return the absolute value of a number. Do you have any number inside? You say, I got 2 numbers. That's a problem. What do you guys need to know how to do? Deduce the answer for what's between your absolute value signs. Meaning, what is -8 minus 5? This is how it's a parentheses in a sense. That's the only sense. So in other words, you have to know the value here first. What's -8 minus 5? Negative what? Good. So this gives you the absolute value of a -13 instead. Now you can what? Answer the question. So what's the absolute value of a -13? 13. You guys see what I'm saying? And that's not the problem we started with. The problem we started with, for example, was, I believe, they made it a lot more difficult. Okay? So, what do you guys notice? You have what? 2 absolute values. And the truth is, you're not going anywhere in giving an answer unless you deal with your absolute values. Do you guys know that? Because you can't perform arithmetic unless you have those particular answers. And so, in some ways, you look at this as a parentheses because you say, although it's not, what do I have? 1 on the left and 1 on the what? Right. So in some ways, you're dealing with that absolute value first, has the highest priority because you kind of think of it as a parentheses, although it doesn't work as a parentheses. So that's where I can understand students go, oh my God, you got these absolute values there now. You're right. And in order of operation, it doesn't even say anything there with absolute values. That's true. Well, which one's on the left? This one? Could you guys tell me what's the absolute value of -7? So this is really -1 times what? 7. You did the one on the left first, minus, and this is -8 minus 5. You told me that's already a -13, but what's the absolute value of -13? You guys see what I'm saying? You're not going anywhere unless you return values for these absolute values. And so now, what sort of operations say? Multiplication and what? You guys want to let me know if it turns off. That red light, you know. Okay, let's see. So I can find my. Did you guys get to find the worksheets online? Did you guys get a hold of those worksheets? Okay. Did you guys get your worksheets? Okay, I might have left that particular worksheet in my office, but all right. Anybody have any questions on those worksheets with order of operation we've been working on? No? Everybody okay with that? You sure? No questions on those? Anybody? Questions on your order of operation worksheets? Where do we leave off? Absolute values. Did we look at some of those? Let's see. Who has the worksheet with them? Anybody? You? Let's take a look. Okay, let's see. Should we look at a couple more of these, or we're at the absolute values? Okay, no, I think, okay, let's do an absolute value. Did we do that one, number 34? By any chance? No? Okay, let's look at this one. Absolute value, I think somebody had a question on this. 5 cubed minus 2. Okay. Nope, minus 3. Then you're squaring this thing. Okay, and then you're subtracting 6. Okay, so this is a continuation of our order of operation. And you guys know this involves absolute value. So for order of operation, we have our please excuse our dear Aunt Sally. So please excuse 3, my dear, for Aunt Sally. And what you notice is there's no what? There's no absolute value here, is there? Okay, so we're talking about absolute values yesterday. And remember that if you're going to give an absolute value, you have to give an absolute value of a what? Of a number. So inside here, you have to have a number. Okay, so we need a number between our absolute value signs here, or these vertical lines. Together, this is an absolute value question. What's the absolute value of some number? If you notice, there is no number here. So what we need to know is what number is here. And in order to deduce the number, of course, we have to follow the rules of what? Order of operation, meaning you have an exponential before you do what? Your subtraction. Okay, you guys okay with that? So, okay, what's the exponential? What's 5 cubed? So 125. So what's 125 minus 3? 122. So the number they're talking about inside is really 122. So you have the absolute value of 122 to the second power minus 6. What is the absolute value of 122? It's 122. And then don't forget that you are doing what with that number? Squaring it. Okay? So this 2 is outside of your absolute value sign. So you have to determine what the absolute value of 122 is first. Happens to be 122. And now you square it. So do we square this 122? I don't know why it looks familiar. Maybe it's the other class. So order of operation, you have an exponential and you have subtraction. So what would you guys do first? Right? Don't you do the exponential before your subtraction? Because exponentials outrank subtraction. Okay, you guys okay with that? All right, now what is 122 squared?
Right there.
What did you guys get? What's 122 to the second power?
14,884.
14,884. Is that true? Okay, then you subtract your 6, and what do you get now? 878. Okay, so here you go. So here's how the absolute value worked. Okay, in this absolute value question. All right, you guys okay with this one? That one, I think somebody asked yesterday about this one. What happens when you square them? That's what happens. Let's do number 36 then. Did we do 36 yesterday? No? Okay, so I always have to remember between you guys and the other class. 36. Let's see what we have. 36. 5 times negative 3 plus the absolute value of 8 times negative 2. Okay. As you guys can see, we have an absolute value here. And if you're going to find the absolute value, you need the absolute value of a number. Is that right? So what you're going to need to do first, really, is determine the number that is here. Okay, and so how do you find that number? There's only one operation. If there's nothing here, if it's blank, what do we know by default? Okay, so this is 8 times negative 2. So what is 8 times negative 2? It's negative 16? Okay. So this question, or this portion, becomes, this is 5 times negative 3 plus the absolute value of your negative 16. What's the absolute value of negative 16? Okay, so you get 5 times negative 3 plus your 16. We have the absolute value. And now really we can use our order of operation. Okay, so we want to remember this order of operation. So order of operation, you have addition, you have multiplication. There's nothing there. That means to multiply. So what do you guys do? You do what operation? Multiply. Outranks the addition. What's 5 times negative 3? Negative 15 plus 16. And what do you get? Positive 1. So there you go. Okay, you guys okay with this one? All right, so let's kind of finish this up. And I want to finish it up with something that students say, let's do number 39. Well, is that one hard, or is that, what do you guys think? 39? Okay, let's do 39. Let's be careful here. I think we only have up to this. So let me erase this previous work. Okay, we'll work on number 39 and we'll call it good. 39, we got 5 times 7 plus 3 plus 5 times 3 over 5 times 8 minus 1. Okay, so let's see how this goes. All right, here we go. So we had a question on this yesterday, or somebody asked this question. What do you do in this scenario where you have a fraction? This is really a fraction. And you have a numerator which is on top. You have a denominator which is on bottom. So how do you guys handle this? Order of operation doesn't really talk about fraction situations, does it? Okay, so what do you guys think? What should you do? Yeah, you're going to say, let me focus on the top portion and the bottom portion separately. So what's going to happen is when you use order of operation for the portion on top, you're going to get a number. And then you use order of operation for the portion on bottom, you're going to get a number. And then we're going to see what we get with these numbers. Okay? Together, they're going to be a fraction. So let's focus with the top portion. And the top portion we know, 5 times 7 plus 3 plus 5 times 3. So what do you guys get here? What do you guys think? Yes, you use order of operation and you see a parenthesis. So we got to do what's inside the parentheses. So you work what's inside, right? This is the work we do inside. So what's 7 plus 3 then? 10. Is that 10? So we get 5 times 10 plus 5 times 3. What does order of operation say again? We got 2 multiplication problems. 1, 2, and addition. Which do we do? Well, we do the multiplication before addition. How do we work that again? Do the one on the left before the one on the right. 5 times 10, what's that? 50. All right, and then 5 times 3 is what? 15. What do you do with these? You add them. So what's 50 plus 15? What is it? 65. Good. That goes on where? That's your top number. Okay, so this is the top number. This is your 65. Let's see what's on the bottom. The bottom you get 5 times 8 minus 1. And now, what is 8 minus 1? What's 5 times 7? That's 35. And that's the bottom number. Okay? You guys okay with this? And then now what I'm going to show you or going to say to you, what you have together is the fraction 65 divided by 35. 65 divided by 35. Now, I'm willing to bet this is number what? 39. And the answers, I don't have the answers. But I bet you they didn't leave this as an answer. Is that true?
Yes.
So what do you guys think they did here with this? They simplified. They reduced your fraction to what? To lowest terms. Okay? And so we're going to use this as an opportunity to do what? To move on to the concept of dealing with fractions and how to do what? How to simplify. Okay, you guys understand what I'm saying? So I'm going to say to you, how do you guys simplify fractions? I'm going to ask you, how do you simplify that fraction?
Divide by 5.
Yeah, it's okay. Let's talk a little bit about this, right? You guys know there's various ways to simplify. Some ways are better than others. You may say, well, what are you talking about? Well, if I ask you guys, some of you guys say, I want to divide, what do I want to do? What's the slowest common what?
Lowest common
Denominator?
Or like a, no, not like the lowest number that they both have is the same.
The lowest, yeah. There's a lot of ways we can say this. With math, we got to be careful. Do you guys know that? Because math is so what? It's so, is there any room for error? There's no room for error. So we got to be careful. There's various ways to do this, and sometimes people say, we're looking for a number that divides both of those numbers. Okay, that's a way you can do this. You're looking for some number that divides both 65 and 35. Now, in this example, maybe you guys know what it is, but it's more than that. You're really looking for the largest number that divides both 65 and 35. And that's a lot easier said than done, because depending on the numbers, you may be able to find very easily the largest number that goes into 65 and 35. And depending upon, the numbers, that may not be so easy. So the strategy of you really looking for and trying to find a number that divides both, or the largest, in my opinion, is only a strategy that you use to get people to start thinking about how to simplify a fraction, but it is by far not the most efficient way. Because one day you can stare at this and find the numbers, and hopefully it comes out in your head, and you go, oh yeah, I know what the number is, 24 or 18, and the next day you stare at the same set of numbers, you may not be able to find it. So when I teach 110, this section on reducing fractions, I do it in a much more comprehensive way that's much more effective in the long run for students, that help you simplify and break down these numbers here, regardless of the size that they are, regardless of the numbers that you see. In other words, I teach people a process of how to simplify fractions that you use for beginning algebra, intermediate algebra, college algebra, calculus, trig, statistics, that you could use for the rest of your life. Okay? So that's what I want to focus on, is really that technique, because in the end, that's going to take you a lot farther than just staring at numbers and trying to find a number that comes out. Okay? So that's what I want to transition to. And so can I erase this problem on the board and we just focus on the 65 over 35? All right, so what I'm going to start to talk about is still review, and some of you guys may know exactly what I'm talking about. How many of you here, we are now going to do what? Reduce